Hey everybody, Mr. Covey here.
And this is Mrs. Lemke, and we're looking at some cool calculus problems.
This is going to be fun. All right, I'm going to start here because I know how to do this.
Great, I appreciate that. I'm going to drink my coffee.
All right, so Mr. Lemke told me how to do derivatives last year, so I'm going to do the antiderivative of this. What is a derivative of cosine? That would be sine of 3x. I'm going to throw it on my plus c. Boom.
Check it, because if you take the derivative of that, don't you run into a bit of a problem?
Well, derivative would be cosine of 3x. Uh-oh.
Yeah, see, there's the problem. You have this extra 3 thing going on, so you didn't get the thing you thought you would get. I think we need to make an adjustment.
What's that called again?
I think it's called substitution.
Oh, so it undoes that chain rule. All right.
Yeah.
Cool.
So it's just basically a strategy to help you deal with the fact that you have a composition or just something that looks kind of strange where you know that the chain rule would be a problem for you. So like Mr. Covey just said, the derivative of a composition of functions requires that you take the derivative of the outside and then you keep the inside layer. And then you take the derivative of the inside. Right? So that's our chain rule written in function notation.
Cool.
What we want to do in u substitution is let u equal that inside function. And you might remember u being special when you were taking ATH. We set you up for this way back in the day. We had some problems where there were u's and they were in quadratics, and we did factoring with that.
Right.
So you might remember that. I bet you've been going over your notes like last night and stuff, things of that nature. So what you do is you let the u represent that inside function, because sometimes all that function notation is just like a little glucky to work with. So we're going to write our function like this, and then just basically do chain rule on that. We'll see that we get the derivative of the outside, keep the inside, and then the derivative of the inside we could write like u prime, but we could also write this. And that gives us a hint about how we want to handle these integrals. We want to have our inner function named, and we want to have its derivative included, so that when we anti-differentiate, we just have to go backwards.
Okay, I think I get this. So if I'm doing the antiderivative of f prime of u du, I just get regular f of u plus my c. And the important thing here is that you have this du on the outside since we're integrating with respect to u. So that little du there is going to end up being kind of the tricky, annoying part of this. And we'll see that in a minute here with an example. So if we jump right in here.
Oh, do we want to go back and talk about your other problem?
Fine. All right. Usually I do problems wrong and then I don't redo them. It works out.
You really should do corrections, Mr. Covey.
Nah. Anyway, all right, so let's retry this problem.
And we have to tell them the really important part.
Oh, about the cloud?
The cloud.
All right, so this here is a cloud. It's a cirrostratus cloud, actually.
I don't know if that's a name, but I like it.
It's a type of cloud.
Is it really?
Yes.
Okay.
And it's really important to use a cloud because otherwise you might forget that weird du part. So we'll talk about that.
It's very critical.
Okay. So your first thing you have to pick is what you're going to make your u, and your u should be that inside function when you're thinking about this as a composition.
Right.
So here it's pretty straightforward. The inside part is that 3x. So you're going to call u 3x, and then right away, inside your cirrostratus, you need to do the derivative of that. So you get du equals 3 dx.
Where did the dx come from?
The dx came there because we were differentiating with respect to u, but then this had x's, and so we got to keep track of that. It's like related rate stuff.
Oh, so I could have said like du dx equals 3, and then moved the dx over? Like, I needed a bigger cloud.
Totally.
Okay, just making sure. You just put some stuff in.
You're right.
I wanted to make sure.
Exactly.
Okay,
So
I'm with you. I'm all caught up.
Okay. When we come back to our problem here, we rewrite the cosine of 3x as the cosine of u. But now we have a problem here. The problem is I want a du here, but if you see du is 3 dx.
We need to put a 3 in the problem somehow.
Yeah, so sometimes I just put it over here. And I say, like, I'm going to put a 3 in there, and I'm going to put a dx in there.
Okay. Can you just put a 3 into a question?
Nah. I gotta throw a 1/3 out there. Boom.
Oh, now you can.
Okay.
Now I support an equal sign there because a 3 and a third multiplied together, that just gives us a 1.
Okay. So now the reason I did that was because if I look at that underlined black thing, 3dx, that's just du. And the reason that that's important is because remember, I'm trying to integrate with respect to u. So,
Oh, okay. So now you have everything in terms of use. That's really good.
and now this is easy. What's the antiderivative of cosine? Well, that's just sine of u. That 1/3 is still hanging out there. I'm going to add the plus c, and I'm done.
Oh, that's really awesome. I like it this time. And the 3 part, oh, wait, you're not done. I just realized.
What did I forget to do?
You forgot to look at your cloud again.
Oh, so you got to go to the cloud at the beginning, the cloud, and then at the end the cloud. Because remember, I'm trying to integrate this function that had
Right. The
x's.
question was about X. The question wasn't about you. You, Mr. Covey, made the thing with the U, the letter.
And remember, you did this when you did U-sub problems in MAH.
That's right.
You sub back in whatever you called U.
That's
at the end.
correct. I totally forgot.
And there's my answer.
I like it. Very good. This. Okay, hi, we're back here to do problem number 2. So in this problem, I'm a little confused starting out because I see like a lot going on, but I definitely can see that x squared plus 2 is a quadratic that's inside of a radical function.
Can I just distribute that in there and then I can just do normal stuff?
Oh no, Mr. Covey, that's not good. That would be very bad algebra. To distribute through the radical, we'd have to write the x.
That always worked.
Mr. Rumpf might have lied on that one if that's what you think he said. I really don't think he said that, but okay. I'm not going to fight about that right now. Okay, so here we're going to write x squared plus 2 inside, what did you call this?
It's a cirrostratus.
A cirrostratus. I want to get the vocabulary down. Okay, so and that cloud certainly that I had there initially way too small. So yeah, this is much better. So I'm going to let you equal that inner function, and then I'm going to take the derivative
With respect to x.
with respect to x, and then over here I'll write 2x.
Sorry, I skipped that step.
That's okay. You're just advanced. You moved things around on me. It was very confusing, but we persevered. And then this dx, you do it like separation of variables, right?
Exactly.
Like when you're solving a differential equation. Okay, so now we have the things that we want to look for in our problem. And I see here, let's look at my problem versus my cloud. Looks like we are all set with the dx. We are all set with an x. We are not all set with the 2. The 2 is a constant. So I can insert a 2 if I balance it with a 1.
Are you tossing it at the end?
What do you, oh, anywhere.
Anywhere, you're
Because
right.
we're just multiplying, right? Isn't that okay? Is that messy?
No.
I can fix that. Anything for you, Mr. Covey. Anything for you.
No.
We can put it right here.
There
Okay,
we
is
go.
that better? Okay, thank you. I want to make you happy. Okay, so then over here, we would have our big globby thing, which is u, and that's going to be u to the 1/2. I'm trying to think ahead to my antiderivative rules, write that as a power. And then the 2x dx, my cloud says that's du. Woo!
Cool.
It's good to say woo in the middle of problems. And then here I have to anti-differentiate. So we'll say u to the, let's see, 1 more would be 3/2. And dividing by 3/2 is multiplying by 2/3. Oh, that just makes me want to cross things out. Don't you love canceling, Mr. Covey?
That looks beautiful.
Especially in red. That's my favorite. Okay, now, did I have to cancel that? No, I could have left it messy because calculus. And then u, look up here. There we are. See, this time I remembered to put it back in terms of x. Thanks for helping me on that before.
Of course.
All right.
How could I check that answer?
Checking. Checking just means you're going to take your derivative real quick in your mind, okay? And so take your 3/2, bring it down in front. What would I have? 1/2 that to the 1/2 power times 2x. That looks exactly like what this is.
So every time I check a U-sub problem, I should be using chain rule to do the derivative?
Yeah, I think that's a fair thing to say.
Cool.
Cool. All right. You're up, Mr. Covey.
Okay. Okay, so this next one's going to look a little weird because it's not as clearly a composition of two functions, but it really is. This is I'll make my cloud, my cirrostratus.
Ooh, looks really good.
There is an inner part to this function. There is an inside function, and that's just the square root of x. So this isn't e to the x, it's e to the square root.
To the thing. Oh, I see.
And that thing is the square root of x.
I see.
I'm going to do the derivative. Be careful. We can do this in our head now. We're getting to be pros.
Are we? Ooh, I don't know.
All right, never mind.
Okay.
Lemke needs a little press.
I need help. I need support.
So I'm going to rewrite it as x to the 1/2 so that when I do the derivative, I get 1/2 x. What's 1 less than 1/2?
Ooh, -1/2.
Come on, Miss Lemke.
That was really hard.
And then remember, I have a dx there.
Okay.
Okay. So if I look back at the original problem, like, okay, instead of writing e to the x, I'm going to write e to the u, looking at my cloud. But then here's where it gets a little confusing. It might help if you clean this up.
Oh, maybe. In the cloud?
Yeah.
A clean cloud?
You always have to have a clean cloud.
You do? Okay, that's good to know.
Yeah, so I'd maybe write it like 1/2, and then maybe put the square root of x in the denominator.
I see it. It's there. I didn't think it was there at first.
It's totally there.
It's totally
there. So it's kind of like right there.
Ish. Yeah.
Ish.
But we need the 2.
Yeah, so
1/2.
So you want a 1/2.
Okay.
So
I'm getting excited.
I know, I was going to say.
Now.
I'm going to put the 1/2 in there.
Okay, cool.
But you can't just put a 1/2 in.
Because you have to balance it with the 2.
Okay.
Right. Because now you actually put in a 1.
Right.
Okay.
So now I have the 1/2 dx and the square root of x. That whole yellow part is du.
All of that is du.
All of that
together. So like all the yellow highlight.
All the yellow highlights du.
Got it.
I still have the 2 out there, and now I'm ready to anti-differentiate. What's the antiderivative of e to the u?
Oh, my favorite.
E to the u. There we go. Toss down the plus c. Don't forget to go back to the cloud.
I'm going to forget that.
You are going to, you're going to get -7.
Oh, shoot. I hate when I get -7.
Yep. And then we are done.
I like it. Cool. That's awesome.
The red one.
All right. So let's take a look at problem number 4. Any thoughts on this, Mr. Covey?
Again, just distribute it in. This was like one of my
There's a problem on the
getting
screen.
angry.
Oh, yeah. Well, I understand.
Just distribute that in there.
Yeah,
It's easy.
no, you can't do that. There's an exponent out here, right?
Oh.
That means you have 5 of those binomials.
It's just Mr. Rome told me so many times that I could do that.
I'm sure. We got to go talk to them about this.
I know.
Everyone does. Okay, so here you have to remember that that's really their 5 times. So you could technically multiply it out, but why on earth? Because it's triangle. That's hilarious. Okay. I'm laughing all the way through the day about that one. Okay, so let's have our cloud. I feel like I'm kind of cramped on the cloud space here, but we'll see. Okay, so you have to think of what thing is like inside something else. So you have a choice of the 3x plus 3 or the x squared plus 2x. I'm really thinking it's x squared plus 2x because that's inside the power thing, right? Now, what if I were to pick something wrong in my cloud? Would that become obvious?
Definitely, because you'd be trying to get that du to show up, and you'd be trying to do that.
Oh, and that's like, it would be sad. And so that's a sad cloud?
That is a sad cloud.
I have to use the business end of the pencil? That's the eraser.
I get it.
Okay, just making sure. You kind of looked at me strangely. Okay, so over here we have the derivative, and then we can move our dx over. Separation of variables kind of thing, right? And,
Not really seeing
Did
that show
I
up.
do this wrong?
Oh, wait.
Can you help me, Mr. Covey?
You can multiply 2 by something to get 3.
Oh, I could. So I think the way I'd like to think about this is to take out the thing I don't like and then put in the thing I do like. Now, I know that that's 2 steps, and you being you probably see it all as one. Half a step for you. I'm going to do like 3 steps maybe. Okay, so I'm going to just go back to my integral problem, and I'm going to factor out that 3, because I can see from my cloud that 3 is not present. Okay, that's just going to help me in general, I think. Okay, so all I did, I know that's a lot of writing for just factoring out, but I feel like this is helpful. I can factor out that constant.
Okay.
Okay, then I'm going to go to my cloud and say, I really want that to be 2x plus 2.
Double it.
Yeah, so put in a 2 and balance it with a 1/2. Ah, on the edge. Okay, so The 3, I just took out, like this morning, I had garbage collection at my house. I had to take out the trash. And so like the 3 is like the trash. You just kick it to the curb.
Wow.
I'm just saying.
Harsh.
I know. I didn't really kick the garbage to the curb. But you know what I'm saying here. That's my analogy, right? The 3 was non-helpful. Take it out. And then do the regular insert balance thing.
Okay.
And now I think we can take the 2 and the x plus 1 quantity and the dx. All of that is du.
Cool.
That was a lot. I don't know if we're going to do any harder math this year. This is the peak right here. This is the pinnacle. Okay, and then we are going to have our antiderivative to the 6. I'm going to be really fancy here. Are you ready?
Yeah.
Instead of writing a u, I'm just going to go right here.
There you go.
So I don't forget that step. Boom.
Cool.
All right.
I like it.
Thanks.
Ooh, one with trig stuff.
Oh, you got to have some tricks.
I always get confused about the sine squared thing, even though I learned it in ATH like 22 years ago. So I'm gonna just
That's hilarious.
I'm just gonna write it like that, just for my own brain, and because it might help me with this.
Oh,
problem.
I do think that will help because that notation is not calculus friendly.
No, it is not.
It is.
Okay, so we're gonna set up the cloud for this one with you guys, let you guys finish it out, and then we'll show up the answer. So we're gonna set up our cirrostratus there.
Can we have a lightning bolt on it?
A light.
light?
Oh, like in the cloud.
Coming out.
Cirrostratus clouds.
Have lightning bolts? Okay, I'm just asking.
It's amateur on here.
Okay, sorry.
All right, so when I pick the inside part, it's a lot easier to tell the way I rewrote it here. It's like I got a sine of 8x and I got a cosine of 8x. So it's pretty clear here that the sine of 8x is the one with the exponent, so that's the one I'm going to choose is my u.
Yeah.
Okay.
And again, if you did it backwards, I think you just end up with like some kind of du with an exponent on it, and that you never want.
Right. Looks very wrong.
Yes.
All right, so I'm doing my derivative of u with respect to x. Then I can do that little rearranging, separation of variables.
Oh, thanks, Mr. Covey.
There we go.
That's great.
All right, so now my cloud's ready to go. I want you to,
We're pretty close. I'm excited about this question.
I am too. I want you guys to pause the video, go ahead and finish this on your own, unpause it, and then we'll show you the answer. Okay, so here's my work and what you should have gotten for your answer down there in the bottom right in the box there. And again, remember, you can always just take the derivative of that and use chain rule, and you should end up back with what you started with as the original problem.
Oh, that's really comforting that I can always check my work. I really appreciate that. That's
As
wonderful.
long as you're willing to put in the effort, Ms. Lemke.
Well, sometimes. Well, I think this kind of wraps it up. I mean, it wraps it up for you and me, Mr. Covey, maybe not for our listeners here.
That's
our,
true.
Our listeners have 8 more problems that they could try. And where could they find answers for this?
There are no answers anywhere for any of the problems.
That sounds really funny. We should do that.
No, directly on this video, there is a answer key that Mrs. Lemke made on Schoology. So you should try the 8 problems and then check your answers. Don't just look at the answer key and copy them down, please.
That doesn't help you do anything except maybe some hand-eye coordination work.
There you go.
But that's really, that's some calligraphy practice. That's right. But, you know, we want you to learn the math. So try those 8 questions, see if you did them right. And if you did, you are in great shape for the practice we're doing the next couple of days.
All right. See you guys later.
Bye.